Let's look at the types of matrix that we'll come across in this chapter. First is your column matrix. So basically in this it has only one column. So we have a say matrix B, which is a column matrix. It would look something like this. Say 3, 4 and 5. So there are 3 rows and 1 column. That's your column matrix. Next we have row matrix. Row matrix has only one row. Again, just know what are they. In time you'll understand how they are useful. So here we need to understand the general representation. So please observe this. We have a matrix A. The elements of the matrix is represented by Aij, wherein we have the number of the order to be m by 1. Here it is 1 by n. So that's the difference. Is a column matrix of the order m by 1, row matrix of order m by n. Right? This general representation too, you guys have to get familiar. Okay, so already we have been introduced. It's not that hard. So in time you will get used to. We have numericals on that actually. Next is a square matrix. Here the number of rows and columns are said to be equal. So let me just do this. So a matrix in which the number of rows are equal to the number of column is said to be a square matrix. So pretty much all the things that we have seen. Just a second. Okay, we are back. So the compiler had crashed, so I had to do this. So this is not a square matrix. We have here 16 by 24. And see, you can see here, it is not a square. Well, it's not a square. It's not square in shape. This one is a square matrix. So here it would be around 4 and 4, that is 8. 4 and 4, that is 8. So this is 8 by 8. So this is an example of a square matrix. So square matrix will have the same number of rows and columns. So basically 4, 5 sine theta minus 42. This is a square matrix. Now we have diagonal matrix. A square matrix which has only diagonal element which is non-zero and everything else is 0. That would be your diagonal matrix. Let me give an example. So here we have 8 by 8. It has to be a square matrix. Along the diagonal, values has to be present. And everything else should be 0. Not can be, should be 0. Of course, even the diagonals along the way we can have zeros. That's not an issue. So let me show this graphically. So that is your diagonal matrix. So along the diagonal we have different values, but everywhere else it is 0. So let me give an example. 4, not 5, sorry, 0, 0. Then we have not 2 again, minus 2, 0, 0, 0, 6. That is a diagonal matrix. So this is say matrix B and this is say matrix C. So this is 3 by 3 and this is 2 by 2. Right? So here we can see the representation of matrix B with the elements Bij with the order m by m, wherein Bij is equal to 0, where I should not be equal to j. That is, all this are, see, this one is A11. This one, in this case, it will be B11 actually, because we are representing that way. B22, B33. So here I and j are equal, but everywhere else they are not equal. Right? For example, over here, this is B13. Agree? First row, third column. So those are 0. This is what the representation is talking about. With this particular definition on a code, I'll be able to produce a diagonal matrix. Okay, so again, all of this representation is important. My emphasis is on this. Everything else is quite simple. It's not a hard set of definitions. It's very simple though. Now, scalar matrix. A square matrix, which is a diagonal matrix. And along the diagonal, we have the same set of values that is said to be a scalar matrix. Okay, so it's very much specified over here. So let me give an example. 4 0 0 0 4 0 0 0 4. That is your diagonal matrix. Not sorry, it's a diagonal matrix also, yes, and it's a scalar matrix. Right, so here again, look at the representation. We have a square matrix n by n. The elements are represented by bij. Bij is equal to 0 when I is not equal to j, that you guys know. For example, let me write an example for you guys. B12, right? B3 1, so on and so forth. While when it comes to B11, B22, B33, so on and so forth, it has to be a fixed value. K can be any value. It can be 2.14, it can be cos theta, it can be anything, but it has to be the same. And finally, we have identity matrix. So it's a square matrix, it's a diagonal matrix, it's a scalar matrix, but here the diagonal value, the k value will be 1. It's very useful, the identity matrix, that I'll show it to you guys in time. So again, the definition is very simple. If I is equal to j, it is 1. If it's not equal, it's 0. Pretty much everything could have been represented this way in the set builder form. But yes, knowing how to read all of this representation is very important for me. Because all the documents that you will read, they won't have just numbers. They have symbols, a lot of symbols. You take up any science stream or any statistics in any domain, you guys will see such representation and you guys should be very comfortable in reading and understanding them. Okay, so that's why I'm emphasizing wherever I can. Now pause, copy all of this. Oh yeah, one last thing, zero matrix. So this is the one which we have used over here, to be honest. Zeros. So zero matrix, matrix is said to be zero matrix or a null matrix if all the elements are 0. So this particular thing over here generates a 0 matrix. So basically all the elements are 0. So that you guys can write your own example.